I hate electrolyte.
So I have two worksheets that we're going to see if we can get through, and maybe if there's not a class in here after this, we can stick around a little bit longer. So first question is gonna be identify strong, weak, and non-electrolytes. And David, what's a quick explanation for the three of those?
Electrolytes are strong acids. Electrolytes are weak acids.
Yeah, that don't dissociate whatever at all, right? Or insoluble salts, right? Okay, so looking at the first one, C6H6, do we think that's going to be, it's a covalent compound, right? Because it can just contains carbons and hydrogens, also known as a hydrocarbon. What class of electrolytes do you think it's going to be? Hey, Rich, do you know how to turn all the lights on?
Yeah.
All right. What do we, raise your hand if you think it's non-electrolyte. If you think it's strong electrolyte or weak electrolyte. Yeah, so non-electrolyte is going to be the correct classification for C6H6.
You know it's not electrolyte.
Because it's a covalent compound, just contains carbons and hydrogens. There's no salt, it's not a salt, right? Because there's no metals. So, all right, next one is, does anyone know the
You say off or on?
on? Does anyone know what the compound B is?
Not sure.
It is not acetic acid. Acetic acid would be CH3 COOH. It is not a base either. It's not methanol, it's actually ethanol. Because
that's non-electrolyte.
Yeah, so this is also a non-electrolyte.
Is it because it's also all just all together, right?
It's a covalent compound again. Yeah, it's a covalent compound that doesn't contain a nitrogen. I'll show you what we'll see later when you have a nitrogen in a covalent compound like this. Okay. So this is non-electrolyte as well. All right. From this middle area, only this middle area, okay? What is C? So we got, raise your hand if you think it's a non-electrolyte. Strong electrolyte. Okay, I saw some of y'all raise your hands after you saw other people raise their hands. Is it a weak electrolyte? Okay, so we have, do we all agree that lithium is a metal?
Yes.
Nitrate is a polyatomic anion. So this is a salt. Do we agree on that?
Yes.
The salts are only found in two classes, strong or non-electrolytes, right? Because as David said earlier, soluble salts are considered a strong electrolyte. Insoluble salts are considered a non-electrolyte. So because this is a salt, we have to determine whether it's soluble or insoluble. And David, what do you say lithium nitrate is soluble or insoluble? It's soluble based on what two things?
Lithium's a group.
Yeah, so lithium is in group 1, so it's going to make it soluble regardless of the anion. But also nitrate is always going to be soluble. So this is going to be extremely soluble salt. Okay.
That's strong.
Strong electrolyte. All right. Here we have a covalent compound for D, but it contains a special element that for this class is going to put it in a certain class of electrolytes. This is the nitrogen. And do we know what? Colin, what do you think? It's going to be a weak electrolyte because it's a weak what? A weak base, yeah. So
Why isn't it non-electrolyte?
because, like I said earlier, when you have nitrogen in a covalent compound, it's very basic. It's going to be a weak base.
Or any other elements that can make it?
No, not for this class, okay? You're gonna see nitrogen in covalent compounds. Like this is a nitrogen, but just because it's not in a covalent compound means it's not basic. That's just a soluble salt in C. But because NH3 is a covalent compound that has nitrogen, it's going to be basic.
If you have a covalent compound with nitrogen. Or it's
A weak base, which means it's a weak electrolyte. Yeah. All right. What about E? That's what it says. Yeah. Are we agreeing or are we disagreeing? I would be on the fence about this one. Or would I? Pentane.
You're guessing us.
So, does it help you? Does it help you if I give you the formula for it?
Yes.
C5H.
Oh, yeah, it's non-electrolyte.
Yeah, non-electrolyte. And you'll see it with a you'll see the formula on your test because this worksheet I made like 4 semesters ago when they actually had to know this stuff. Guess what? Y'all don't have to anymore. So, yeah. All right. Next one. And let's start doing. I want to get through this fast. So okay, so non-electrolyte, and someone tell me really quickly why. It's insoluble because it's silver, right? So it's an insoluble solid. And then benzoic acid. How do you know it's a weak? Yeah, it tells you it's an acid. Is it one of the strong acids? No, that means it's automatically a weak acid. So it's a weak electrolyte. All right, how about we move on? Okay, let's do these 2 over here.
Methamphetamine.
That is not methamphetamine. Okay. So methylamine is CH3NH2. What do we think about that? Nitrogen in a covalent compound. That should be giving us vibes of a weak base, right? Pretty weak to me too.
It's pretty weak there.
So it's a weak base, therefore it's a weak electrolyte. And then glucose. It's a strong what?
I want to say it's a non-electrolyte. Oh, because of glucose. Glucose doesn't have the nitrogen.
No, but we're talking about electrolytes. We're asking, does it dissociate? We don't care if it dissolves.
Oh.
We're asking, does it dissociate? Because yeah, you can dissolve salt or sugar in water, but is it going to break up into ions? And the answer is,
Oh, it's not electrolyte.
yeah, it's a non-electrolyte because sugar dissolves in water. It dissolves in water, but it's not going to dissociate in water. When we're talking about electrolytes, we mainly care about whether it can dissociate. All right, so this is a non-electrolyte. All right, we're gonna move on to these. We can go back to those if we so desire to. Identify the type of reaction and predict the products for each of the following. Hey David, could you do number or letter B? The 3. Everyone, make sure you draw it up or write your equation and everything. So predict the products and then identify what kind of reaction this is. Got it, David? Megan, I'm gonna have you do number or letter A, okay? All right, what are the products, David?
The sodium nitrate.
What's
Phosphate. The precipitate is lead.
So would you say this is a single displacement reaction, a combustion reaction? Yeah, so it's a precipitation reaction because we produce an insoluble salt products. All right. What do you get for A? Okay. So, but it would be a double displacement, right? But if you wrote out the net ionic equation, we would see that there's no reaction, right? Because all the ions. So, good job.
You also be double the stick.
Yeah, but it's more specific. It's a precipitation reaction because you form a solid at the end. Yeah. Well, these are both ionic compounds, right? Sodium nitrate and lead or phosphate. They're both ionic compounds, but we know that this is the solid because we know phosphates are generally going to be insoluble, and lead with a +4 charge is not an exception to make it soluble. So because that's the case, that's going to precipitate out in solution. That makes sense? Cool. All right. All right, what do we get in this in F? You
Be a single displacement.
one.
Displacement.
Okay, so zinc chloride, you said, what's the formula for that? Is that going to be aqueous, or you said aqueous or solid? Okay, yeah, aqueous, right? And then is that all that's produced? H2, right? So in general, when we have an metal like zinc, which can displace hydrogen, and you would need an activity series to see this, which you will be given if you need it. You produce a salt and then hydrogen gas. So H2 gas flows out of solution, the atmosphere. All right. Want to do some of these? All right, let's do G and H. Give you 2 minutes to work on both of those, and then so. All right, well, work on the. Don't have to do it. This is not very good.
I thought it would be,
Going on.
I thought it would be in this class. Welcome to Michael's STEM major.
So like, chloride is gonna be. Except in certain cases when it's like a polyatomic ion, like any of those that are like. They're all gonna have different oxidation numbers for it, but in general, when you feel like that. It'd be like- 2 minutes.
All right, let's go over these reactions. So before I go into what the products are, what type of reaction is letter G? Combustion.
Oh,
Yeah, it's a combustion, right? Because you have some sort of hydrocarbon here, some carbon plus hydrogen compound. And the reason why you know it's combustion specifically is because of this oxygen gas right here. So in combustion, you're always going to react with oxygen gas. What are my products? CO2 and what? Yeah, CO2 and H2O. Those are always going to be your, okay, I mean always, like 95% of the time, those are going to be your products in a combustion reaction. Know how to balance these because they get complicated sometimes. How would you balance this reaction? Yeah.
Okay, I found 1, 11, 7, 8.
11, 7, 8. Let's see if that's right.
That might not be right.
So if I put a 7 here and an 8 here. So
11 is
16 hydrogen, 7 carbon.
14 plus 8.
22 oxygen.
Yeah, exactly. So there's 22 oxygens right here. And let's okay, let's do this the old fashioned. So 14, right? So 22. So yeah, that's 11 here. 11 oxygens. All right, so those coefficients were correct. 1, 7, 11, or 1, 11, 7, 8. 1, 11, 7, 8. So my point being, know how to balance out the reactions. What physical states are my two carbon dioxide and my water in?
Gas and oxygen. Gas and liquid.
Gas and liquid. Are you sure? Are you sure you're sure?
Are you sure you're sure?
I'm sure,
Yeah. Yeah, it's gas and liquid.
They're both gases. So carbon dioxide obviously is a gas. And then you give off steam in a combustion reaction. Steam, as you know, is water and it's gaseous. So gas, another gas. All right. Any questions about letter G? Yeah.
Oh. And that's
So me personally, here's how I do. So first I balance out my carbons. So I saw that there's 7 carbons, that's why I put a 7 in CO2. And then there's 16 oxygens, or sorry, 16 hydrogens. So I put an 8 there because 8 times 2 is 16. So I want to make that equal. So 16 here and then 14 here, or what am I doing? Okay, so 7 here for the carbons, 16 for the hydrogens, right? Those are good. The reason why these are so difficult is because the oxygens are the most difficult to balance. So there's a 14 for the oxygen, right? Here, and then there's an 8. So 14 plus 8, that's 22. But we have 2 oxygens over here. That's why I added an 11. Oftentimes, you're not gonna see it this way. Sometimes it could be an odd number of oxygens. In which case you add the odd number of oxygens here. So say there was 23 oxygens here. You'd add this 23 to the reactant side and then double everything. That's how I do it. So it would be 2, 14, and 16 in that case. But only do that when the oxygens are odd. The oxygens are even, you're good. Just divide it by 2. That's how to do it quick.
I would balance this carbons and hydrogens. That's the option. Easy to manipulate the option. So balance carbons and hydrogen, save oxygen.
All right, so next we have NH3 ammonia plus oxygen gas. All right, what are my products here? NO2, H2O. What I thought, or what type of reaction is this? It is indeed a combustion reaction. Wait a minute. I thought combustion reactions only had carbon dioxide and water as the products. Yeah, so it's the 95%. This is the other 5%. Honestly, it's because you can't spawn a carbon from nowhere. So there's no carbons on my reactant side, so there's no reason why there should be a carbon on the product side. So instead of CO2 for this one, it's NO2. And the same principles of balancing apply. So how would you balance out this reaction? We got some coefficients. 4, 7, 4, 6. 4, 7. All right, let's see. 4 nitrogens, we're good. 12 hydrogens, we're good. 14 oxygens, 14 oxygens. But yeah, in case you didn't get that so quickly, here's what to do instead. So 4, 7, 4, 6, that's the final answer. So here I'm gonna my nitrogens are balanced, so we're good there. So I'm gonna add a 3 in front of these hydrogens here to balance them. That'll increase my reactant number to 6. So I'm gonna put a 2 right here. Oh no, now my oxygens are not, or my nitrogens are not balanced. So I'm gonna put a 2 right here. So we have 4 plus 3, 7 oxygens. So the total number of oxygens is odd in this case. What I'm gonna do is add my odd number here, then double everything. So in this case, what we have is the correct answer. 4, 7, 4. That's how I balance these in like less than. Goes on the test times everything. All right, any questions about G or H?
No questions, we're gonna. So this is probably how you'll see. So it's not a multiple choice question, but it's going to be worded similar. It's going to say something like, which of the following of these compounds is a strong electrolyte? And it's going to be multiple choice answers. But this question is saying, which of the following a weak electrolyte when dissolved in water? So it's kind of like a question you might see on your exam. I should go ahead and do this. It shouldn't take, ideally it shouldn't take longer than a minute for this problem because you should be able to identify everything pretty quickly. But if you have to go over a minute. So the way I would, if I was taking this test, I would say, all right, we're looking for a weak electrolyte. So that means everything else is going to be either strong or a non-electrolyte. So nitric acid, I know that's one of my 6 strong acids. So that answer choice A is gone. And then potassium, I see before I even read the second part, I know it's going to either be a soluble salt or a strong base. But potassium hydroxide, strong base. So that's not the right answer. NH3, maybe you forget, you go on. And then sodium, don't even have to read the last part to see this, because it has sodium, it's gonna be either a soluble salt or a strong base, but because this is sodium nitrate, it's gonna be a soluble salt. Let's see how fast we can, by process of elimination, we see which one's the right answer.
Oh, wait, because. Polyatomic ion.
Yeah, so that's how I would go about doing that. Speed is everything. Be like Lightning McQueen. I am speed on the exam.
I
Okay?
was all about.
All right, number 4.
Time slow.
What mass in grams of magnesium nitrate are required to produce 250 milliliters of 0.075 molar solution? If you I think this would take me. I'll give you all a minute, if that's fair. Minute and 10 seconds. All right. Time is almost up. 10-second countdown for Papa.
30 seconds.
Are you Mr. Armin?
15. And time.
All right, time is up. So this is probably the easiest, like, you should probably be praying that you're getting this type of question on the exam today. Because this question shouldn't take longer. If you've been doing your homework, you should know what to do fairly quickly. So if I was taking this test, I would obviously read it. What mass in grams of magnesium nitrate is required to produce 250 mils of a 0.075 molar solution? So I know that I'm gonna need, if it's asking for mass of magnesium nitrate, I know I'm gonna get moles of magnesium nitrate. And I already know from homeworks and everything that to get moles from this given or these given units and numbers, we have to use the molarity equation. So you get 0.0750 molar. And we multiply that by the volume now, which is 0.250 liters, because they gave that to us in milliliters, trying to trick us, but we know it has to be in liters, right? This will give us some number, which is 0.01, and that's moles of magnesium nitrate. And then I already know, well, I just got my moles of magnesium nitrate. I need to get my grams of magnesium nitrate. And there's something that we've been doing since high school chemistry, and that's using the molar mass to get grams, right? So this is nothing new. At this point, it's something that we've done for the entire semester so far. So 1 mole of magnesium nitrate weighs how many grams? How many grams? One, 4, 8, 3, 3, 0, 5. Is that good? 305. Okay. And doing this or putting this into your calculator, what did you get? 0.7 grams of magnesium nitrate. So this is the easiest question you're gonna get calculation wise. It only gets more difficult from there. But this is just a good problem to really get on. I guess it's the simplest problem you're gonna get. So everything else builds on this, on these types of conversions and everything. So now we can skip number 5 because someone told me that was a bad question. All right, number 6. I'll give you, this one might take a little bit longer because it's not just asking for the concentration of a compound, but it's a reaction that's happening. So I'll give you, let's say 2 minutes. Really try, guys. At least write down what you can get. I lied, it's not a reaction. I didn't even read it. Sorry if I confused you. No reaction. What did you just say?
You're all in the hubris.
I'll be walking around, so just flag me down if you have a question.
Raise your hand if you have an answer. Keep pushing.
One unit. Maybe bromine atoms. It's the same. Now we're asking. It's. I think it's like, what am I doing? Okay. Oh. Asking for. Okay. I might have confused. Divided by. Yeah. All right, you can go over it.
All right.
Let's say my rounds.
What is the concentration of the bromide ion? 25 milliliters of a 0.5 molar AlBr3 solution combines with 40 milliliters of a 0.35 molar NaBr solution. Assume the volumes are additive. All right. So what is concentration equal to again? Moles over volume. So molarity equals moles over liters. I'm gonna change it up real quick for this question. So for Br minus, right? Since we're finding the total bromide ion, we have two things here. I'm gonna say total moles divided by total. So total moles over total volume. Let's get the moles first. So for this AlBr3, right? How do we get the moles from the stuff given?
Here is multiplied by 0.
Yep, that's exactly correct. So 0.025 and times 0.5. So what's my moles gonna be? Equal to? 0.0125. Yeah, that's right. 0.0125 moles. Is this the amount of moles we want though? No, what do we want instead? 3. So yeah, we're gonna multiply it by 3 because we know that for every 1 mole of AlBr3, there's 3 moles of Br minus. What is that gonna be equal to? 375? 0.0375? That's about right. 0.0375. That's the moles for one thing. All right. How do we get the moles of the NaBr? So yeah, we're gonna do the 0.04 times 0.35. What do y'all get from that? 0.014. Perfect. Don't need to do anything else with it. Are you sure? Are you sure?
Wait. Is there 2 bromides there?
Are you sure?
There's only 1, so I think I'm chilling.
Yeah. Moral of the story: trust your gut. So if there's 1 mole of, so there's 0.014 moles of NaBr, right? So if there's moles of NaBr, it's a 1-to-1 ratio. So for every 1 mole of NaBr, there's 1 mole of Br minus. So basically what I'm trying to say is there's 0.014 moles of Br minus. All right. We got our total moles now. We can just add them up. What about the total volume?
Add the moles. Oh, you want total volume? I mean, add the volumes up.
You add the volumes up, so 40 plus 25, so that's 65. So you have 0.065. So this is gonna be equal to 0.014, that's plus 0.0125 over 0.04 plus 0.025. When you solve that out, what do you get?
79.20.
0.7923. What if we wanted to account for sig figs?
Or 0.79, because there's two sig figs in like every single.
Are those two sig figs in every single thing? There is not.
Oh, there's three. My bad.
There's 3 in everything except the 0.35.
Yeah, so it's just 792.
But you always go with the least amount of sig figs in the problem. Since this 0.35 has 2 sig figs, the final answer would have 2.
Oh, yeah, that's what I meant.
So you get 0.79. What are the units for this?
Moles over liters or.
Moles over liters
Molarity.
or capital M.
Yes.
Alright.
Take the moles off. Okay.
Yeah, the capital M means moles over liters. So same thing. All right. Any questions on that? Yeah.
The molarity of.
Oh, yeah, my bad. 0.0375 should be this one. Yeah. Does that change your answer at all?
Oh, he said it right.
Oh. Yeah, okay, I just had it wrong, okay. Yeah, point being, yeah, it should be. All right, any questions on that? Right? Let's do some solubility rules. So that's probably gonna be like one of the most important things on your exam. Which reaction will result in a precipitate? Option A, option B, option C, or option D, or multiple? Well, it may be all of them, it may be none of them. That's not multiple choice.
That's no reaction. The second one's insoluble. He's insoluble.
Why don't you talk to your neighbor?
We get partial credit on the exam if you're like the brick.
Probably not.
Oh, no. Yeah,
It's not C.
oh yeah, no, it's not C. Because it's calcium, or I mean calcium. It's what is calcium? But it's K is on top of the solubility, not getting displaced. Yeah, D. What's going on with D over there? I don't know.
On the test,
It's acidic.
20, 25, like
Yeah,
26.
that's
Richard,
Wait, what?
Wait, has a strong acid.
Hmm?
Are you actually saying
Actually, what? Yeah, I was the one.
Are you a saint? The Cowboys.
No, the Cowboys suck.
Wait.
Don't tell my girlfriend I said that. She's a Cowboys fan, and a major Cowboys fan.
These Dallas fans. But their fans are worse.
And that's technically true, but not.
Like,
think you're a bear.
it's
We had Drew Brees. Which other quarterback licks his hands like 20 times before he snaps the ball? No, I just like the hand licking he does before the ball. All right, back to this stuff. Raise your hand if y'all have an answer to this question. I think that's enough for us to go over it. All right, raise your hand if you think it's A. Raise your hand if you think it's B.
Not really.
Raise your hand if you think it's C. Raise your hand if you think it's D. The A's have it on this one. A is the correct answer. Well, let's go over why B, C, and D are not right. So what are my products for B? Water and sodium sulfate, Na2SO4. Are either of these insoluble? Well, we know water's.
Water is just water.
Yeah, water is water. It's not soluble or insoluble. So yeah, and then sodium sulfate. You know that anything with a group 1 element is considered soluble. So we can go ahead and get rid of option B. All right, what are the products for C? Potassium bromide, calcium chloride. Now, are either of these insoluble? No, because again, anything with a group 1 element is soluble, aqueous. And then chlorides are normally soluble, and is calcium one of the exceptions? What are the exceptions? So it'd be lead 2+, right? Pb 2+, Hg 2+, copper +1, and silver +1 as well. So these are all your exceptions for halogens. And this one's also aqueous, so we can cross that off. All right, what about D? Zinc iodide, NI2, and what else? HNO3.
All nitrates are soluble.
Not only that, what type of acid is this? Strong acid, so it completely dissociates. So this one, slap a big old fat aqueous on here. What about zinc iodide? Yeah, it's soluble, and because zinc is one of the exceptions. These are the exceptions for halogens. So this we can slap on another aqueous. All right, that just leaves us with option A. But let's figure out what the precipitate actually is. So what are our products for A? Yeah, the FeS and what else? Yep, just regular old table salt. Now, which one of these is insoluble? FeS. Why?
Well, except
Sulfur is normally soluble.
but it's soluble exceptions.
Yeah. Sulfur is normally insoluble, and its exception, or iron isn't an exception. Therefore,
Insoluble.
insoluble. And we're gonna go with option A on this one. All right. Here's some oxidation number practice. What is the oxidation number of molybdenum in MO04 2-? All right, we got a lot of +6s, and the +6s are correct. So what is oxygen normally? -2. What is molybdenum normally? I'm sorry. Well, what's the oxidation number of molybdenum in this case?
+6.
Why is it +6?
Because it's still -2 after, so that means it has to like, because that's -8, and then if we're at +6, you get -2.
Yeah,
Yeah, they have to.
yeah, it has to add up to -2 basically, right? So you have -8 + 6, which equals -2. So the answer is C.
So the charge on oxygen is -8 because there's 4 atoms of it, but it already has a charge of
Yeah, so like one oxygen's -2, but there's 4 of them, so you multiply by 4.
-8. And +6, that wouldn't cancel it out, would it?
It's not supposed to cancel out. So it's supposed to add up to the charge of the ion. In most cases, it does cancel and it's zero. Yeah, -2, yeah, there you go. All right, any questions on that? All right, let's see what we got next. Oh, here we go, solubility rules.
Yeah.
You should already have these memorized. Got two gentlemen right here whipping out their phones. A third lady whipping out her phone. A lot of phones being whipped out today. All right. Let's do this.
Yeah.
This is boring. Are there any ones with no? Oh, okay, this is the last problem. All right.
There's another worksheet. Hit the back button,
My mom wants me home by 12.
back button. And worksheet 6.
Oh, that's boring. That's boring. All right, let's do this one. Number 4. A new element, trichonium TK, was discovered that has properties similar to the alkali metals. Write a double displacement reaction between trichonium nitrate and cupric chloride. Might see a similar problem to this on your exam, maybe.
The old exam question.
Oh yeah, it was. From like 5 years ago. Fall 5 years ago, fall 2017. Thirty seconds. Yes. I don't believe so. No. Only if it asks you for the state. He'll never ask you to like write out an entire reaction. It's kind of hard to do on the iPad. It might be like, what's the physical state? So you only have to enter like one state. Too bad, but you won't ask you to like write out the entire reaction. They use it for like that stuff. Yeah, in the case that he asked, I just put like S for solid, G for gas, AQ for aqueous.
But if you put solid,
He'll give you credit for, but
Make it.
that's why oftentimes they'll ask you like, what is the sum of the coefficients? Enter all those. Also, he wants to see if like your adding skills are still there. All right, let's go over this. So, trichonium nitrate. What is that going to look like? Compound. EKNO3. You have this, and then what's cupric chloride again? UCl2. Oh, I could trick y'all, but not today. Why is it CuCl2? Ic, so anytime you have like an ic in front of like a Latin name, it indicates the higher charge. In this case, for copper, it's +2, so CuCl2. All right, now what are my products? Or chloride, but trichonium chloride, so TKCl. And then what is my other product? Yeah, CuNO3 too. So this is my final double displacement reaction. So let me ask you all a question. Say I had a question like this where, let's say triconium was a halogen now. That property similar to a halogen would, or, okay, let's say that triconium was a halogen. It had properties similar to a halogen and specifically heavier halogen, like chlorine, bromine, and iodine. My question to y'all is this, what type of electrolyte is this? Wrong electrolyte, exactly. Can't trick y'all today. Because you know how I said heavier halogen, right? So this is similar to HCl, HBr, HI. All of which are what type of acid? Strong acid. So if they're strong acids, they're what type of electrolyte? Strong electrolytes. Boom, there you go. So if you see a question similar to that, you know what's asking. All right. We're a bit over time. Is there anything else y'all wanna go over real quick? You wanna do it real quick? Yeah. All right, sure. I think it was worksheet 4. All right, write a molecular total ionic and net ionic equation. So molecular, right? What type of reaction is this? Specifically? Precipitation. When I ask you to pick between double displacement and precipitation, precipitation is the correct answer. So what are my products here? Yeah, the products.
That is going to be sodium nitrate and silver chloride.
Exactly. Sodium nitrate, silver chloride. If we were to assign our physical states, which one's aqueous, which one's solid?
Nitrates, sodium nitrate is soluble.
Yep, soluble, and then AgCl, they're solid. All right, molecular, this is our molecular equation. That's all you gotta do. Write out your balanced chemical equation. Is this reaction balanced? Yeah, everything has a +1 charge, everything has a 1-to-1 ratio. All right, total ionic, this one's the annoying part. You gotta break almost everything up into its ions. So sodium plus aqueous plus Cl minus aqueous plus Ag plus aqueous plus NO3 minus aqueous plus Na plus aqueous plus NO3 minus aqueous. What do I do here? Yeah, you don't break it up. This is a solid. It doesn't break up. AgCl.
They have a solid relations.
Yeah, I was gonna say they're like a married couple, but yeah, that works too. All right. So how do I get from my total ionic to my net ionic?
Eliminate the spectator.
Cancel out spectator ion. So goodbye, good riddance, lucid dreams, and armed dangerous. All right. So we have all of these spectator ions canceled out. What's my net ionic equation gonna look like? AgCl, solid. All right, that melodic whistle at the end signals the end of this session. We'll stick around for a bit if y'all have any more questions. Other than that, don't think about chemistry for the next 5 hours. And yeah.
About that.
Oh.
So we'll
Yeah.
be doing chemistry for the next 5
For our practice test, they didn't have any history on it, but it's still gonna be on our active test, right?
Maybe, most likely.
Most likely.
I have a strong hunch it's gonna be on.
They're gonna ask like, what did Oppenheimer do?
Oppenheimer's physics is not a chemist.
Like they're hugging.
Yeah, but we don't care about. Care about that.
All I know is like, how would I sign a statement? Like, how would I know?
It comes from the memorization of those. Oh.
I'll have to go after.
Ionic problem.